Hey boys and girls, we're in Reno and we're at Redwood and we're going to be talking to JB Straubel in a very, very short period of time. I am thrilled to be here and let's get right to it.
We will first go down and look at our battery receiving and storage.
Okay.
So we keep, as I mentioned before, we keep our live cells stored outside.
Holy doodle, is that it? The big white thing?
This is it.
Oh, hey, you know what? Can I'm pretty sure that Eric wants to take pictures. I'm probably the wrong guy to sit in this chair.
You're fine.
Holy mackerel.
Yeah, so this is quite active. We're processing, this material constantly, and you'll see pickups going up to our recycling operations. We have trucks incoming, and again, this is just live material. We don't store finished goods or other things out here. It's really to manage the fire risk and human safety.
Wow, how many acres is this, or square miles?
This particular site, this is maybe 25 acres. So what you see out here is kind of a mix. We have things in wooden crates that are often modules or packs. We have whole EV packs, like some of these in front of us here, that are actually in their original enclosure, and we have them for different reasons. We also have some, what are steel drums or plastic drums that are full of smaller format batteries. They're not full of any liquid. They're just, to contain the battery and hold them safely. But a lot of these wooden crates, these crates are all batteries, every single one of them, different makes and models.
Wow.
And we do have thousands and thousands. It's kind of.
So what does problem solving mean? On that sign right there, it says
it maybe doesn't have the proper packaging, or it maybe doesn't have the proper, coating. We may not know exactly what it was. These are some, huge packs. These are a couple hundred kilowatt hours per battery pack. These are smaller ones, all different types of EVs.
This is
and you see every
something I wasn't expecting.
And you
Nice.
see every one of these EV packs, these are, I believe, a truck.
I would guess.
So these are all, something that, we would like to be able to repair and reuse, in a stationary setting. And we work with the OEMs involved in each case. And of course, we have to make sure that there's the right level of function, but there's the opportunity. Some things are really, truly end of life. They may have been in a flood or a fire or something like that. We get those materials too.
Wow, this is, you show me the overhead view. This looks a lot more dramatic in person.
It does give an impression, when you're here in person.
Yeah, it definitely does. Yeah.
And this is still the early days of batteries coming back from the field, but because, we see sort of the good, the bad, and the ugly of this, it's a chance for us to really learn and to iterate.
The good is this is all reusable. These are, well, not all of it, but some of it's reusable, and that's better than recycling any old time.
And ultimately,
get a second life out.
And ultimately, all of these different materials are reusable. The elements inside can all get reused. There were some old Roadster modules I saw over there.
Wow. So how long did it take to collect all of this? I mean,
this is pretty dynamic. This is we'll process through almost all of this over the course of less than a year.
Yeah.
So this is a few months of working inventory.
Wow.
We're receiving dozens of truckloads every single day. Yeah. So all of these batteries, we receive batteries here, the live material. Inert material we receive inside, it doesn't go outside.
Yeah.
But after, being sort of unloaded there, we will do some kind of sorting, grouping of different materials together in the way that we want to process them. And then we will take it up to what we call our calcination machine, our calcination production line.
Yeah.
And that's the first step for actually physically recycling the end-of-life batteries.
Yeah. So you mentioned that, I can't remember the word you used, but inert, I think. But that would be like offal, or what we'd call swarf, right?
Exactly.
So it's the stuff that never made it into a battery. So the outside edges, the swarf, the scrap, offal, all these things come to you, and they go directly into these recycling warehouses.
That's correct.
Yeah, factories.
And we can store them at higher density inside. We can rack them. We can put them on.
Hold on a second. It never fails. I always forget to turn this damn thing off. It's somebody who's probably trying to sell me insurance or something. Sorry about that. There you go.
So the inert scrap we can store indoors, and we can
Yeah.
store it at higher density. You know, we can put it
Yeah.
on racking. You know, we can close pack it together.
Yeah.
Because it doesn't have the same kind of fire risk that an actual battery does. So this is all part of our campus here. You know, these are different operations. We'll come back through here and take a look at some of them.
And the reason is because there's no electrolyte in these offal and swarf. Yeah.
Correct. There's no electrolyte, so therefore they're not really active. They haven't ever been charged.
Yeah.
Because the battery is generally built in a discharge state, so
Right.
it's kind of at a lower energy storage state. Once it has electrolyte, and once it's been through the formation process and gotten its first charge, then we have to treat it more carefully. So up here, this production line we've driven up to is that first calcination unit. This is an in-house machine. I mean, we've pioneered this technology. This is about Gen 5 of this technology for us. We've built most of the machine. I mean, the engineers inside of Redwood are doing the design of this and running it, writing the software for it.
Yeah. So my guess is you'd have to, because I don't know of anybody that says, buy a big recycling machine from whatever company. You're the pioneer here, so everything here is an invention, I would guess.
It really is. I mean, we've built the conveyor systems, we've built the loading, we've designed the sort of heating mechanism itself, all the off-gas treatment, and what we do in this operation is essentially making the battery inert. So before you can shred or mechanically disassemble a live lithium-ion battery, you need to discharge it and make it inert.
Right.
Get the electrolyte out of the mix, and that's really the function of this process, is to in bulk, in an automated way, discharge the batteries and remove the organic materials, and that's what we're doing here.
Okay, so how do you do that? You boil it away, or heat it until
we do a little bit of
Is it a
heating
vapor?
in an inert atmosphere. So
Yeah.
we don't want to burn anything, because we're trying to minimize CO2. That's
Right,
one of
yeah.
our goals.
By
But if-
burning, I just meant you'd vaporize it somehow.
Exactly. So
Yeah.
we basically put it through that rotary tube there, and that heats the batteries and all the material inside of it up to a few hundred degrees C. We don't want to melt anything, because that's
Yeah.
too much energy and it mixes everything together. So we heat it up enough that organic materials like the electrolyte or adhesives and binders and
Yeah.
some of the foams and plastics will kind of break down a little bit and almost turn into hard carbon. So they're more brittle. And then we can, and also any residual charge that was left in the batteries or the modules will, in this case, turn into heat. So that heat is what powers the
that's
whole
what-
thing.
Okay, so the batteries go in kind of like raw and probably partially discharged. Then you roll them around in this thing, which kind of excites them so you can get some heat. And that heat then is used to vaporize whatever's inside, or vaporize and turn it into carbon.
Yeah, and we have a quite extensive control loop that our engineers write and constantly keep improving, that runs this whole thing.
Wow.
And we manage the gas flows and we manage the material feed rates to keep the temperature in the right range. But this doesn't use any natural gas. We don't even have natural gas at this campus. So we use a little bit of electric heating to kind of start it, almost like the starter on your engine.
Right, yeah.
But then we turn it off, and it runs, in a usual, campaign, it'll run 24/7 for several weeks on an end before we do a maintenance event. And when it's in a steady operation, we don't need to add any extra heat.
So I see some pipes. I used to work for a company called Century Spray, and we made pollution control equipment. So do you scrub to pull out the chemicals?
We do.
Yeah.
We do. So after we heat the things up, we end up with a gas fraction. So the
Correct.
organic gases come off.
Yeah.
And then we go and process all those organic gases. We clean them up. We handle that separately. And then all the solids are left behind. The solids contain all the metals. So all the lithium, all of the nickel and cobalt and copper, everything solid is kept behind. So we take the solids into a mechanical processing and separation line. And the gases, we'll drive around the other side of this, and I can show you. The gases, go into a pretty extensive system of filters and scrubbers to recover things like fluorine and any dust that might have been left. I'll drive up here just so we can see it, but then we've got to back up because we are doing a maintenance event, right now. So they're actually in the middle of, redoing some of the sort of processing equipment. We'll go down for a day or two to do these kind of planned maintenance events, but it actually gives us a chance to even get a little closer. And the nitrogen here we just use basically as part of that inert atmosphere. So we want to keep the oxygen away, and we'll purge with some of the inert nitrogen. Well, Sandy, this is Paul.
Hey, Paul.
Nice to meet you, Sandy.
Nice meeting you.
Yeah, so I lead the engineering here on the recycling and refining side. So it's
cool.
a pleasure to host you today and have a bit of a look around.
I'm looking forward to it. Yeah.
Well, maybe we can take a look at module loading
Absolutely. So in our recycling process, one of the advantages we have is that we can take material of any state of charge and form factor. And what you're looking at here is actually the feed conveyor to our thermal recycling process step. So we can actually load the modules directly onto the feed conveyor and then into the process.
And over here we've got
different type of module.
Yep.
You might recognize these things from different automotive, but we don't try and sort of separate one or another. This can take up to maybe 20, 30 kilos at a time, maybe a little more, maybe even 30, 40 kilowatt hours up to that sort of energy level, and load directly in.
We've designed this so that it can take that fully charged modules and
fully charged. No kidding. Wow.
Particular care is taken right at the feed point into the kiln, where we actually need to transfer it into the feed system, because you obviously can get reaction from time to time.
Yeah.
And then into the kiln, where you've got a complex combination of de-energizing, arcing, short-circuiting, and then obviously we're applying heat as well to start the recycling process. So it's all happening at once right at the feed end of the kiln.
Wow. Looks like wood. It is wood. Wow. So your conveyor belt is made out of wooden slats?
No, this is just a coated steel, and that prevents the premature arcing against the steel.
Oh, okay.
Yeah, it's kind of a complex design, even of simple things like a conveyor. I mean, we want the conveyor to be basically fireproof, but also electrically insulating.
Yeah.
So even simple things like that, we've iterated multiple times and learned. Using a rubber belt or with kind of typical metal slats, that doesn't work very well for batteries.
Yeah.
Because things can short and catch fire. So we've learned a lot of lessons there and improved steadily. Well, do we want to try and load one and show how this looks?
Where's going to be a safe place for us to stand?
Not right there.
No. Okay. And this is obviously in various stages of iteration of automation as well, and you can imagine how we can fully automate this as well.
It's using factory style automation, end effectors, and ability to pick and move things. We've taken a lot of sort of learnings from the production process, because basically, what we're doing is unmanufacturing at scale. So we have to think about it in kind of the same way.
Well, the only difference is you got so many different variables here. This would be
Very high variety.
yeah.
Very high variety, and we have to plan for that, and sort of design accordingly. But it's a really interesting problem to solve for. Different than on the new build side.
Yeah.
So
Yeah.
you can see the conveyor. We've started the conveyor there. That's sort of the.
So it's on the way in.
Yeah, so this is about the speed that we'll run at. And this is, I'm not exactly sure which module this is. I think this might be a 3 or a Y module. So this could be a quarter of an EV pack at a time.
Wow.
So it's a fairly large amount of energy.
Quite it's a huge. I mean,
But getting to this scale was important to be able to achieve these processing rates. If we have to do sort of manual disassembly, it takes far too long, and you end up spending more labor than the metals.
Well, we figured there was some kind of chewing that went on, and we figured that there was going to be some method for discharging the energy inside, and then electrolytes are a bit of an issue. So
this
sounds
is that
to me
first
like
step.
you got it all going here. Yeah.
Yeah, this is that first step to discharge and manage electrolytes, and then from there we can go safely and very efficiently also into the kind of mechanical separation.
Yeah. So are we going to get a chance to see that mechanical operation as well?
We can see kind of through a window, but
That works.
we
I'll
don't
take
really
it
want to
in.
go in there because it's a bunch of PPE and things like that.
Oh, all right. I don't want to get my little bunny suit. Is not on the list today. Okay, good.
Well, can we walk inside,
Yeah, we
Paul,
can look
and
around, we
check
can.
it out?
And the speaking to the electrolyte, that we actually utilize the contained energy in the electrolyte to drive the process. So the kiln is indirect fired, electrically indirect fired, and then you're actually utilizing the contained energy in the electrolyte to minimize that energy input. So it's very efficient from that standpoint.
So what in the world would that be?
I was just trying to figure that out. I haven't seen this one before, so it's kind of
Looks like a bunch of air conditioners. Oh,
that's some kind of
NMC.
maybe it's a data center or rack.
yeah.
type
Okay,
of
data center
energy
rack.
storage.
Yeah,
Yes,
energy
yeah.
storage for data.
But this is
center.
the beauty. We can take basically anything that's going to come our way without having to get into a discharge, understand how to interface with it.
Yeah.
So we'll send something like this into the sort of as is, with its
Right.
metal enclosure
Yeah.
into heating, because then we can make the batteries inside of it inert, so that we can safely, mechanically shred it after that.
Yeah.
But to have someone unscrew every fastener and mechanically disassemble this,
there's no money in that. That you'd go broke.
and it's a bit dangerous if you don't
That
have the
too,
proper instructions
yeah.
for every one.
So let me ask you a question. Could you take a complete battery enclosure? Okay, it's everybody. I'm not a big fan, but everybody's got them in aluminum enclosures, right? The battery tray and whatnot. And it'll have a steel lid, and then you've got a tremendous number of batteries inside. Could that be picked up and sent in?
I mean, functionally, that's exactly where we're headed.
Yeah.
And we can do that with, certain sizes of packs. We keep scaling this up, and right now, we can take in battery packs that are, certainly this big or maybe 2-3 times this big. The next step is getting to full automotive scale so that we can put directly in a full automotive pack. And, as the volume and our mix continues to shift, that's the very next step. So in here is where we do, we have our controls center, and also where we do the loading of the smaller batteries. This is kind of a time lapse that shows what we just saw, sped up obviously, but you get a sense of how that works.
Yeah.
And we just run this, steady. Here's another picture of kind of what this looks like when in operation. It looks basically the same, but
So this is the big tube we saw outside that turns around in a circle and excites the
material
batteries.
inside of it. Yep.
Yeah.
That's all part of the gas handling, which we didn't quite drive around to see yet, but we scrub all the gas phase of what comes off completely. But it's
So
pretty.
is there any recycling potential for the gases that are coming off?
For the fluorine, potentially. You know, we do capture. Well, Paul, you can describe.
Yeah, I
the
mean,
fluorine.
we sequester the gas handling system. Sort of comprises a few parts. One, to combust any volatile or toxic compounds that may. Normally they don't evolve, but this is to make sure that we're protecting the environment. Dust removal, so we'll do that through our bag houses, that's a final product, because you can imagine valuable materials are carried through. And then the wet scrubber, that's there to remove your fluorines, your chlorides, your bromides.
Right. Yeah.
And you can actually concentrate them up. The fluorides you can actually precipitate, and we're looking at how to recycle those. So yeah, there is an avenue there. It's one step and part of our development processes. So.
Cool. So I got to ask, what the heck are those?
Oh, those are production records. So when we do production records, we'll present those to our different crews that achieve them, and a bit of a informal way to keep a bit of healthy competition and celebrate our wins. So we got our gong over there as well. So we'll hit the gong, and it'll be accompanied with the belt. So,
Transfer the belt.
Yeah, the transfer of the belt. Right.
We have a big glass thing that somebody gave me a long time ago, and it's the High Achievement Award. You're allowed to park anywhere you want in the parking lot, and coffee's free. Well, it's free for everybody as well. So
Nice.
it's kind of we don't have a real High Achievement Award, but I'd like to know the guy that's going to walk around with that thing. And it looks like you got to be a big boy for that one.
So in here is where we're loading the smaller format things, and smaller size batteries. Outside are the bigger modules. In here is smaller stuff. So watch our step. You can kind of get a sense of, these are, I don't even know what this is, a jump starter thing, or power tool batteries, things like this.
Oh yeah.
So, this is all stuff that is also recyclable. It's lithium ion of different chemistries.
Yeah.
But, we work and recover the same, nickel, cobalt, copper, lithium elements from these batteries as well.
So you got quite a
watch your step over this here.
Yeah.
Yeah, it's quite a volume. This is only a few hours of material. We typically don't want to store too much inside.
Yeah. Wow.
So one of the other types of production scrap or swarf that we see is still a live battery. So
oh really? So it just didn't come up to charge or something, or
exactly. Maybe it came all the way to to the end of line final inspection, and then it was deemed to not work okay. So some of these might be in that category, I think. Hey guys. Try not to.
A lot of 2170s, it looks like.
Yeah, so these are basically cells that have, for whatever reason, came to an end of a production line, and did not test out good. So maybe they had some internal defect or something like that, and it's usually a very small percent of manufacturing. Of course, everyone is working hard to make that a small percent, but even if it's 5 or a few percent, that still adds up to a lot of material, and someone has to safely deal with it.
Yeah.
So this is also a big portion of what we process and deal with.
Huh. And I've never seen them boxed before, ever. Normally they come in a 55-gallon drum.
We'll take a look at what this one is.
Oh, there you go. Now that's what that's what I was expecting to see.
So these
look like they've been recovered from a swamp.
Yeah, these are kind of a mess. These either were flooded, maybe that was the case, or maybe they were, some people intentionally dunk them in salt water to try and inert them.
That's exciting.
But it kind of creates a bit of a mess for us to receive.
Wow.
But we recycle these too, same way.
Could be recovery from fire events as well, from recycling collection centers.
They look ugly, but they still have a lot of valuable materials inside of here, and this is not something you'd want to put in a landfill.
So what do we got here?
These are just some of the products that we make out of this line. So,
really?
I mean, this one, for instance, is, you can see it mixed ferrous material. So you know, it doesn't look that different, but this is a bag of basically scrap steel. So in that mechanical processing you saw, you know, we will take aluminum, copper, ferrous, and the active powders, they all go into separate places. So we'll aggregate enough until we have a full truckload. You know, we can mass out a full semi-truck, and then this will go off straight to, you know, steel recycling, and then another batch will go off straight to aluminum, you know, melting and recovery.
Yeah.
Or copper. You know,
Wow.
I think this row here is the powder line. So you see the bag is a little more full.
Yeah.
You know, this bag we can either sell direct, or we also have our own internal refining operations to go further and to start to recover, you know, lithium and more direct elements out of the middle of this.
I see.
But from here, you know, there's no more batteries at this stage. Now we're into sort of chemicals and sort of, you know, powders and components. So this operation that we're standing in was the first step, going from battery to materials like this.
Yeah.
Then there's, you know, further steps to go into refining and into manufacturing.
I would just call this the money line, because quite frankly, that's the cash, right?
Yeah, I mean, we're able to sell this directly. It's it's got a lot of mouths to feed, though. You know, we have to pay for the whole operation and recover all the capex.
Yeah.
But we are doing this profitably. I mean, we're able to do this competitively with the cost of mining.
Yeah.
That's something a lot of people ask about, is like, oh, is this worth it at all? And it definitely is. You know, even with everything we're doing and seeing here, we're not subsidized. You know, there's not some handout to do this.
Yeah.
Literally no federal subsidies at all right now. And still we're able to sort of make a living of it, make a business of it, selling these same elements back to the market.
Well, I'm a capitalist. Everybody that watches this knows that I believe in, you know, you invest and you get a return on your investment, and that's how the country was made. So I moved here. As soon as you get too much handout, things turn ugly and inefficient. So
changes the whole
I'm
incentive
delighted.
structure. So.
Well, it changes the culture, and I don't want to do that. So this is really quite good, and I assume that this is normally filled up, but because we're doing maintenance over here, you've only got a couple of bags.
Well, we're only down for a couple days. You know, that's not a long maintenance event.
Yeah.
So these were probably in between what we had queued up for a full shipment.
Yeah.
Because we want to only send out full containers. You know, it's not efficient to send one pallet.
Exactly.
But we could maybe look at one of these bags. I'm not sure what's what here. Yeah, so...
I'll tell you one thing for sure, it's really hard to crush a 4x4. I don't know how much this weighs, but...
I mean, this is pretty heavy. This is 830 kilograms. So
kilograms.
So we're looking at about 1 ton of material here.
More than a ton, more like a ton and a half. Yeah, this is heavy. Yeah.
And this is after we've removed all the aluminum, we've removed copper and anything that was magnetic. So this is now a very dense, fine powder, which is highly concentrated with nickel, cobalt, and lithium.
Wow.
So this is quite valuable and kind of the next step in the refining journey, you know, going from battery back to the critical minerals. It's kind of complicated because we have so many different factories and lines and steps here, but this operation is, you know, sort of after the calcination. So once we have gotten the material into a somewhat concentrated state, then we can do chemical refining on it. So this whole production line here is basically doing that sort of more detailed refining. So we're dissolving the material that is the powder, we're dissolving some of the nickels, and we're dissolving the lithium, and we're able to separate out, you know, lithium and nickel and cobalt into their own constituent products.
So is this like floating or?
Well, we don't use floating exactly. That's kind of more of like a hydrophobic process. Yeah. You know, this is actually, in this case, we're dissolving some of the metals. So the lithium is physically dissolved.
Yeah.
And then we reprecipitate it, and one of our products here is lithium sulfate, a very pure lithium sulfate.
Yeah. So are these the containers you put it in?
Well, this is actually the product here. So these are various kind of I'm not sure what all that is, but I know this is our lithium sulfate product. So unfortunately you can't see it very clearly here, but you can see some of it kind of that's maybe spilled on the bag. It's a pure white powder.
Yeah, I've got bags of it or little jars of it in my office.
Yeah, so that's
people always think that lithium is black, and
no, well, this isn't metallic lithium. First of all, this is a salt.
Right.
We never have like a bar of lithium. It's always the
Yeah.
compound. But this compound is lithium sulfate, and it's like a pure white.
Right.
But it's interesting that this is 100% recycled, and as we said, one of the second or so largest sources of lithium in the entire country, right here being recycled.
Yeah. Yeah.
But this whole plant is, really built to do that dissolution, separation, and concentration of those different materials.
Cool.
Sandy, this is Guillermo. Guillermo's in charge of.
Nice meeting you. Nice meeting you. Yeah.
Yeah, Guillermo's in charge of our cathode active material plant and all the engineering here.
Cool.
Yeah, we've been designing it for about a year and a half now. Everything that's going into the building, and then some of the equipment that we're designing ourselves as well.
Yeah.
So we're entering off to the side a little bit here, but I'll show you where the raw material will be coming in from. So these are our main dock doors, and so trailers will be pulling up next to it, and we'll be unloading them. And then the material goes through into those back rooms, and there's a set of pneumatic conveyors that basically convey raw material, which is basically in powder form, up to the third floor, almost 100 feet up.
Yeah.
And then from there, it goes through several processes, and it comes down from the third floor down to the first, cascading and getting processed as it goes through. And then it goes back up. There's a total of 8 pneumatic conveyors. So there's 3 floors, and it basically does a cascading effect 8 times as it goes through the plant.
So you just mentioned pneumatic. So I'm gonna do a quick thing. The reason for using pneumatic conveyors is because dust explodes no matter what it is, including everything. So the reason you use pneumatic is because you don't want any electricity anywhere near it. A spark could blow up the whole building in about a heartbeat. So normally in the machine tool world that I came from, we only use air for breathing. But when we had to do things where there was going to be a lot of dust, or when there was going to be something like we did a bunch of liquor, like the stuff you drink, and so barrel handling, dumping, and whatever, you would actually get dizzy walking around because there's so much
the fumes,
so much fume. So everything there was pneumatic. So pneumatic has got a place.
So there's 2 types of pneumatic conveyors that we're using.
Yeah.
One of them is dilute phase, which is
Yeah.
high air velocity,
Right.
and you put the powder through it and it gets carried with the velocity. But the one we use the most here is dense phase. So you're basically pushing a slug of so it's no longer like that airborne dusty particle. It's all kind of compressed.
Yeah.
And so it also prevents and mitigates those types of issues. But on top of that, abrasion and other things are mitigated by the dense phase.
Oh, great.
We go take a look at the kiln.
So over here we have,
okay.
This is our main kiln. This is where the bulk of the chemistry is happening inside these kilns. It's called a roller hearth kiln. And if you'll see it, it's basically like a big pizza oven made out of ceramic bricks, and it's got ceramic rollers.
Oh wow!
And you pour the material into these like trays made out of ceramic, and they go through the process. This is the RHK for line 1, and they're now building the RHK for line 2.
It's a fairly big oven.
Yeah, we can look inside that one because that one's still going together.
These are some of the biggest in the U.S. This is the only plant in the U.S. to make this material for sale to outside parties.
Yeah.
So, when we talk about the battery supply chain needed in the U.S., this is. Yep. Thank you. We're right in the middle of it.
So you can see this. This is basically our kiln, and these rollers they're driven from the outside, and the saggers, which are the trays that go through this kiln, ride on these rollers. And there's several heated zones to follow a specific temperature profile that we need to hit, and different reactions are happening in different zones of the kiln.
This looks a lot like a vacuum brazing operation. It had the same kind of, we don't do that anymore here in the States, but same sort of a deal with the ceramics and stuff like that.
Yeah.
Where in the world did you, who is the supplier of this stuff?
So we bought this from a company in Japan.
It's from Japan.
Yeah.
Okay.
So some excellent technology there. And,
and they know the most about ceramics, without a question of a doubt. The best ceramic ball bearings come from Japan. And you know where they get the sand? They get it from Egypt. They don't use anything else but that.
Well, in a way,
So-
cathode material is a ceramic, actually.
It is, yeah.
It's an oxide. It's a very, very highly engineered oxide powder.
Right.
It's a ceramic powder.
Yeah.
So metal oxide. And we have to go to very high temperatures. I mean, almost to 1,000 degrees Celsius. So we're we're up above the melting point of most metals at that point.
That's
why
why I was
even-
touching this is.
Well,
I don't
that's
know
not
what
the
this is.
actual roller, I don't think.
these
That's
aren't
just
the-
a-
Inserted. Yeah,
the
the
act-
rollers will be ceramic as well.
Yeah.
They're actually a like a carbide ceramic roller. The aluminum would melt.
And did y'all see the kilns upstairs, up in Building 8?
We took a quick look.
Okay,
Yeah.
so those are stainless steel, and they have a coating on the inside that on its own, the stainless steel won't survive the chemical attack and the temperatures that we're subjecting it to. And that's half the temperature that this is going to.
Yeah. This is plenty hot. 1,000 degrees Celsius is. So are you depending on the thickness of these things then to basically not allow the oxygen to escape, or worse yet, something else come in?
So we have basically flow through the whole inside of the kiln. And by the way, the other kilns will also be a very high oxygen environment. And the flow is running counter current. So if the saggers are running one way, the oxygen's running the other. And we have basically a series of dust collection, picking up the oxygen and recirculating it.
Wow. This is brilliant. And this is all you guys. You designed all your own stuff.
Yeah, I mean, there's some great suppliers supporting us, but I mean, the factory design, the details of the whole process flow is Redwood. There's a lot of engineering to it.
We've come a very long way too, and we were just looking at we did a lunch and learn, and we just looked at what the plant looked like a year ago, and here where we see concrete, it was basically dirt, and we were getting ready to pour our first footings for these columns
1 year ago.
1 year ago.
So all these batteries are creating an intermediate DC bus that is in these red and white wires in the troughs. They feed over to these inverters, which are making 480 volt three-phase. So there's a ton of DC power from that whole array feeding these inverters. And then after those inverters, they can go to the larger transformers and get stepped up to intermediate voltage, where we can tie into the solar array to charge it, or feed into these data centers that are right behind us. Drove by. So this whole thing is, basically its own power plant, totally off grid, solar and battery power plant running those data centers.
So I see a huge number of, you got doubles, never mind. I just didn't see, I was trying to figure out why there was a whole bunch of red and no black, but it's just somebody laid the red ones on top.
I think I can miss all the wires here.
Oh yeah, no problem.
Am I clear on your
Even
side?
if, yep.
So you're really seeing the front lines of it here. I mean, we're like right in the middle of commissioning, and we're building, and we're working on this stuff real time.
And this is really,
There's a lot of electrical work
really
to do.
amazing.
And now here you see kind of an up-close view of what that solar looks like. So you need a lot of solar to feed, these data centers, but this is kind of a unique way of doing it, where we lay it just right straight on the ground.
And then you
And
just
again,
drive
there's
a little robot
There's a little
over
teeny
it.
robot in that little hut you see over there that comes out and sweeps it off.
Like a pool cleaner.
Looks a little dusty right now because of all the construction, but that thing does dust it off pretty quickly.
Hey everybody, we just walked through the facilities here at Redwood. JB, thank you so much. This has been brilliant. I tour a lot of things. This one really was mind-blowing. But now what I'd like to do is you gave us a brief when we came in. Should have filmed that one. But at the end of the day, you've got some amazing stuff going on here. And I'd like you to describe the first slide basically that I saw that I really was impressed with, and that's the Redwood's role in battery ecosystem. I mean, it's going to shock the daylights out of quite a number of people, quite a number of our viewers. So if you could, that would be great.
Well, yeah, it's my pleasure to show you guys around and host you. And Redwood's role in the battery ecosystem is really below the surface in a way. We don't make electric cars, we don't make batteries themselves, but we do almost everything else. So as soon as a battery comes to anywhere near its end of life, we will collect and transport, store that old battery, or even the production scrap materials if they contain some of the critical metals and critical battery components. And the first stop along that journey for us is trying to reuse it. So as much as possible, we want to do diagnostics, we want to understand, is there any usable life left in that battery pack or module? And then, as we talked about and saw, we're starting to deploy second life energy systems that can extract some of that remaining life. Even if it's just the tail end of the life, it's still very valuable to get to reuse it. After that, we go into recycling and refining. So then we can move into some of the calcination operations and mechanical separation and sorting operations, hydrometallurgy. There we can recover the nickel and copper and aluminum and steel materials, all the different metals that make up an EV battery pack. And we're able to sell those directly today. So a lot of our scope is in recovering and selling those materials. And then finally, our last step on that kind of journey is building back those materials so that we can sell them directly to the US and domestic battery industry. And that's where we're manufacturing cathode active material, or CAM, or cathode material. So our first major factory to do that is what we walked through today. And that factory is using a high percentages of recycled lithium and nickel coming from the refining operations.
Well, the thing that really shocked me was when you told me how much life expectancy you've got out of some of these things. It's mentioned when we went through the tour of the battery facility, or the where you're storing them, but it's worth mentioning again because totally it blew me away.
In terms of remaining usable capacity,
yeah, right.
Well, in a lot of cases, we'll see batteries that have maybe 50 to 80% even of life remaining. And things come to us for a lot of different reasons, or they reach end of life for a lot of reasons. And sometimes that's because of loss of power capability or loss of ability to fast charge. And that still can be a pretty damaging loss of function in a car. You don't really want your car to lose 80% of its horsepower. But in our case, in our application, because we're using the battery more slowly and we're not trying to fast charge it, we can extend the usable life by kind of changing the specification. So in a way, we kind of adjust the rules of the game a little bit to expand the window of life.
Well, the other thing that I kind of was interested in was it's an integrated business that you've got, and you've got basically multiple revenue sources. In the tour, we got a chance to see bags of almost 3 tons each. It's amazing. To me, it just blows my mind to see, in essence, truckloads of junk. Basically, most people would look at it as junk. And at the end of the day, all these different revenue streams that you've got. Can you go through a little of that?
Yeah, that's a fun way to describe it. I really enjoy trying to find value in those truckloads of junk. And we have these, as you said, 3 revenue streams, main revenue streams. The first one is energy storage, where we are selling projects and functional energy storage services to stationary energy storage from second life batteries. Yeah. The second revenue stream is from intermediate materials that we recycle and refine. So that looks a little bit like a mining operation, even though we don't have a pit mine or something, but we're selling materials in the same way that a mine would. And then the third revenue stream is the cathode material, where we manufacture the material and are selling a very high spec, precision, powder that goes into battery manufacturing directly.
I guess we should try and touch on one thing that I think is kind of important, and that is the feedstock. This was another thing that most people kind of think, you get a bunch of batteries and you chew them up, but that isn't quite the case. Can you elaborate a little?
Well, it's complicated. We get a lot of different types of material, different chemistries, and also different sizes and shapes. And a big percentage of our material today is actually still production scrap. So it's not even a full battery yet. It's something that came out of a manufacturing facility or a gigafactory along the way to being made into a battery. But it still has the same valuable critical materials that we want to recover and recover as much value from as we can. So we process that in a similar way to end-of-life batteries. And the total quantity of material has been growing steadily. We've seen almost 60+% growth year after year after year in the amount of feedstock coming to us, now for more than half a decade. And when we started this, we were maybe a little too early in some ways. There was a small amount of material, but we've been investing, we've been building the capability, and today the quantity is really pretty staggering.
Well, I was very shocked to see, probably the slide that'll be going up right now, I was very shocked to see how much on those graphs is like the baby blue color or whatever. That just totally blew my mind. I was really impressed on how much scrap you're recycling, because at the end of the day, this is where it's not as hard to recycle. And because it's never been energized, it doesn't have any issues with catching on fire or anything like that. So I think that that's something. You said you started too early. I guarantee you, there's a Chinese thing. When's the best time to plant a tree? Yesterday. Second best time is today. So you planted a tree yesterday and then some. And I think it's flourishing. I'm totally blown away. I really am. Yeah, well, the thing that I thought was impressive was how much profit you're turning, which I thought was interesting, because I've got a whole bunch of friends that say things like, you'll never make any money. So you got like something like 200 million based on, I don't know what your total revenue is, but.
Well, that is revenue. That's not profit, just to be clear. So.
Okay. We'll change that around.
The recycling operations that we saw, those are profitable. We're able to make a positive return on those operations. So, that is counterintuitive. A lot of people think that recycling, can't compete with mining, and that may be true with some materials, but it's widely disparate depending on what it is. And batteries happen to be something that can be profitably remanufactured and recycled. And we're really showing that today. So several $100 million of revenue from just battery recycling and keeping those materials out of the waste stream.
And something like the tonnage, 55,000 metric tons, is that's quite a few tons.
Tens of thousands of tons of avoided disposal of batteries.
And the number that comes to mind for the run rate or whatever is something like 20 gigawatt hours.
I like to try and think of things in terms of energy storage units, and gigawatt hours per year is kind of the metric that most battery factories are judged on, and battery supply chain. So, for Redwood Materials, we think of how much are we processing, and today it's around 20 to 25 gigawatt hours per year of material that we collect, move, store, refine, and then also sell back to the market.
Not only that, you do it, you made the investments, but you do it for next to free because you make your own electricity and probably sell that off as well. So to some folks.
We do have a lot of solar capability and are, no natural gas on the whole factory here in Nevada. So, we try pretty hard to, engineer the facilities in a way that is sustainable and both economical and sustainable both. I think they have to go hand in hand in order to keep scaling.
Yeah, absolutely. So can you, we got a chance to drive around and this campus is huge, literally huge. And kind of describe what we're looking at here.
Well, so the project that we got to see here is one of our large Second Life energy storage projects. And this one's quite interesting because it's actually operating as a microgrid. So, there's a significant amount of solar, about 20 megawatts of DC solar generation, which is, charging up a Second Life battery array, the biggest one in the world, in fact, about 60 megawatt hours of energy storage in over 800, former EV battery packs.
Yeah.
And all of that the job of all that is actually running a data center. So we're running an AI training data center, with that solar power, which is, stored up and buffered and delivered 24 hours a day to run those computers. And all of that not even connected to the grid. So we're able to do all that at a very competitive price of electricity, which is even slightly below the cost of the utility. The cathode building, yes, that's the new cathode manufacturing factory. So, kind of a different business unit for us, but that factory is where we're actually manufacturing the cathode material. And I think, we got a chance to walk through and see some of the kilns, which are, doing the actual lithium intercalation into the material. So
the thing for me was that you designed it and built it in under 2 years. That
very quick.
That totally blows my mind. I talk to people and they want 2 years to think about it. Or to create a plan. I really don't understand how it is that the rest of the United States has moved into near reverse, and you guys are just killing it. It's just amazing here.
Well, we're trying to go fast. I think some of these things are urgent, and the industrialization of the supply chain is urgent. So we try and work with an urgency in everything we do, and we sometimes make a few mistakes along the way. It's hard to go fast and be perfect at the same time, but I kind of aim for like a 80-20 or a 90-10 balance where we were right 90% of the time, but it frees us up to really go fast, try innovative things, have fun while we're doing it too, because I think it's a little more fun actually as an engineer and technologist to be able to try interesting new ideas and not have to engineer it for 5 years to be 99.99%.
Well, at the end of the day, people who don't make chips don't make anything, and that's the rule that we had when I was a kid. Some things have to be scrapped because they didn't quite work. But Henry Ford I said, "Failure is the opportunity to do it again right the second time." So, and you seem to be doing that. There's a program that is being pushed right now, Industry 2.0, and you are living proof that it can happen. So,
well, thank you. Yeah, we're trying and growing the team and adding people into it who are excited to operate in that same way.
Right, and we also mentioned that you're doing something that nobody else is doing, and that is training tradesmen. We got plenty of other folks. We don't have nearly enough tradesmen to try and compete on a worldwide basis. So that's another feather in your hat.
Well, and we're not alone entirely doing that, but I think we're trying to sort of show how it can go productively and partner with community colleges, partner with the education system, around us, to really begin to pipeline it so that when people come to the end of that, wherever the end is for them, there's a really productive job waiting for them. There's a hunger for their skill set.
Well, there's a need, and quite frankly, I went to a trade school. I started into the trades, I went to the trade school when I was 14, but I started into trades 2 years later. And quite frankly, that's what gave me the edge when I got into engineering. And I think that we've missed the boat on that. So, but anyways, I don't want to get onto that. I start to weep. But Redwood is an example that everybody should be looking at right now of someone or a group of companies or a company that on its own, not begging for money, not getting government handouts and whatnot, built up an operation that's brand spanking new in a part of the country that most people probably wouldn't travel to ever, and not only making a go of it, but basically leading the planet. Like, I was surprised that I can't remember the percentage that you have of the market share. It's absolutely amazing to me. Can you just elaborate a little on that?
Yeah, I mean, as you noted, we don't have any federal subsidies or incentives, to do this. This is really pure economics right now driving this, and our investors who have helped, get this started and invest their own capital and some of mine in making this go. And today, through years of building that out, we are at, maybe around 70 to 75% of lithium-ion battery recycling market share in North America. There are only a few other people doing this, but it's a hard thing to do. It's not a sort of simple path, and it takes years of engineering.
Well, it's not just takes a long time. It costs a lot of money. I have no idea how much got invested in, because you're private. You're not going to say it anyway. But at the end of the day, you found the people that put the investment in to get it with the vision that you need to have for these things. I didn't see everything, but I was pleasantly surprised to see Ford Motor Company up there at 50 million. It's good that they came and saw the future, as it were. So I'm really lost for words as to what I saw here today. This was really brilliant. I am ever so grateful for you allowing us in. I know you're not a big fan of getting videoed and whatnot, but I'm honored to shake your hand, sir. Well, and I mean that sincerely. Thank you.
My pleasure. I'm more of an engineer. I like building things more than I like being on camera, but it means a lot coming from you. You've seen a lot of amazing things.
Yeah. So. Well, thank you so much, and thank you, Alexis, for getting us together here. So, and thank you for watching Munro Live. Really appreciate it. Stay tuned. There's more to come.